Okay, so my name is Craig Porteous. I am a principal consultant with Advancing Analytics. I'm also a data platform MVP. I founded the Data Scotland conference and I co-organise Glasgow Data User Group. You can get in touch with me on the contact details on this slide. I'll show them again at the end, and if you're watching the recording, now is probably a good place to pause. So I'll dive right in. I'm going to run through the processes, the tools, gotchas for setting up a deployment pipeline with Azure Synapse Analytics. We'll cover a few different tools. So if you've got any kind of deeper questions on those tools or the component parts, feel free to ask me some questions in the chat afterwards. I'll hang about for a little bit longer. But I'll touch on quite a few pieces quite lightly as I go through. If you want a more deeper explanation on the ARM template side of things, then I've got a pre-recorded session as well that you can find a link to in my GitHub repo as well. So to get started, how do you normally develop within Azure Synapse is probably the first question that leads you on to CICD and how you promote code within Azure Synapse. Is it a single environment that you're using where you potentially have developers that are coming in using the same space, potentially using the same data sets and scripts and things like that as users are consuming? So you've got a lot of risk of cross-development conflicts there. It's going to be difficult to test things when you've got people potentially using components at the same time. Hopefully nobody's working with this in this form unless it's a POC implementation, because it does make everybody's life quite difficult. Maybe you're using multiple environments. So that's where you have the proper development lifecycle. You've got dev, you've got a test, you've got production, maybe another environment in between as well, a pre-production. How do you get the code between each of those environments? How do you promote scripts? Notebooks, components and integration pipelines and things like that. So there's a lot of things to consider, and that's where continuous deployment pipelines come in. So let's take a little step back. What is CICD? So that stands for continuous integration and continuous deployment. Although they're lumped together in this acronym, they are essentially two different individual processes. So these processes, starting with continuous integration, CI, it focuses on the testing of your code, the testing of changes, and if necessary, compiling, kind of coming from a traditional software development background. So your developers making changes, there's automated tests that will check those changes and make sure everything's compatible with existing code. And that generally iterates over and over again until you reach the point where you want to make a release to an environment. And that's where continuous deployment comes in, sorry. So with continuous deployment, it's all about getting code deployed to environments in a consistent manner. It's not different depending on which developer is doing it or which person or which team. And it can be done quickly and easily without building up to a specific release. And then you've got a lot of people and a lot of teams at play and working with it. So overall, although they are two individual processes, they focus on consistency and automation as a kind of overall goal. And that's what we want to use with our Synapse environments. So there's a few kind of high level prerequisites before we can start building out a continuous deployment pipeline. The first one is we need to connect Synapse to source control, and that's Git source control. And that allows us to make changes to code. We can actually work on things and not have them completely working before we save and move on. Whereas if you're working with a live environment with Synapse, very similar to Azure Data Factory, if you can't get it working, you can't close that window if it's in the live version. Secondly, we need multiple environments to move the code between. So there's no point in having a deployment pipeline if you've got nowhere to deploy it from and you're only working with a single environment. whether that's 3 environments, as you can see on the screen there, or that's 4, or maybe even 2, that's fine, just as long as there's a clear definition between where development takes place and where people will consume this information in code and data sets, etc. And then finally, it's not just a technology solution, it needs process as well. And that's where the last piece comes in, and that's what's demonstrated there is feature branching, but some sort of branching policy so that developers can work without stepping on each other's toes and potentially developing the same piece of code and clashing. So feature branching is a good way to do that. So how do we apply this to Synapse, and how does that affect the deploying of Synapse? So thinking about Azure Synapse as a whole, there are 2 main parts to consider that you can break it down into when we're deploying between environments. You've got artifacts on the left there, and you've got resources on the right. And the resources are essentially everything at the top level. It's the workspace itself, it's your SQL pools, your Spark pools, the overall security, the connected storage account as well. And these can primarily be handled by using ARM templates, but there is that key distinction that we need to handle them separately. Your artifacts are everything that's inside your Synapse workspace. There is a caveat though, that there are components that are just not handled by either of those when we're doing that deployment process. Your Purview connection is going to be specific to your Synapse environment and can't be brought over when you're doing that continuous deployment pipeline. And within SQL dedicated pools, you have to handle the database objects separately. And actually, Kevin Chant just released a fantastic blog post, I think it was yesterday, on this, which I'll provide a link to at the end, and also put in my references file in my GitHub repo, where it goes into detail about deploying your database objects for dedicated pools using a DAC pack. So that's definitely something to look into if you've got that component. So thinking about these 2 separate parts and how they differ, we've got resources, we've got artifacts. Both of them rely on ARM templates. Essentially, your resources can be built using ARM templates. Your artifacts have an ARM template that's generated by Synapse, which I'll go into demonstrating later. With your resources, you can have that set up in a DevOps pipeline, and that deploys to a new environment. You can deploy that for all of your environments. You can create your dev, your test, and your production environments using those ARM templates, which is great. You can do the same with artifacts, but you will hit problems with certain components. Some of the components within the list of artifacts that I went through will deploy using ARM templates, but other components like notebooks, for example, are not ARM resources, so they will fail when deploying to a target environment. So it's always better to just treat your resources with the ARM templates, or maybe tools like Terraform, for example. But your artifact should be dealt with in a more specific way, which I'll go into in a second. So how do we deal with the artifacts? And these are the tools that we need to consider. You're starting off with your repository, your Git repository. We've got options of using Azure DevOps. You've got GitHub, there's Bitbucket in there, or any other Git-based source control. When we bring that repository into our pipelines, we then start to get restricted. When we're dealing with our pipelines, we are limited to using Azure DevOps because that artifact component has to use the Synapse workspace deployment marketplace extension within Azure DevOps. So that means you're locked into using Azure DevOps pipelines. And because of the way Synapse connects to Git source control, you're also limited to GitHub and Azure DevOps as the source control options. So that eliminates those other pieces which you might be able to use when you were using the resources component for deploying the ARM templates. So once you've got those components set up, we've then got a choice to use a YAML pipeline, which is file-based, which you can actually store the pipeline within source control as well. It's easier to control, or the classic method, which is using the user interface. Now, there's a lot of blog posts out there that go into detail on how to do this using the classic method and some of the setup components, most notably from Bradley Ball at Microsoft. So definitely check them out. But I'll go into covering the YAML process where you can store that within source control, and it's easier to deploy, it's easier to use and move to another environment or another installation if you require it. What does a good CICD process look like? And I'll kind of run through what the process looks like, and then I'll demo all of this in a minute. So you're starting with your development environment. You've got your feature branches that your developers are working on. You've got a development branch. So once the developers have completed a piece of work, for example, they would then bring that into the development branch, and then they would pull that into the main branch using a pull request. And potentially you've got automated testing using a continuous integration pipeline that checks the code, makes sure everything looks okay, make sure it integrates with the rest of the code that's there and everything's passing checks. You would potentially do that between your feature and dev branch or your dev and main branch. And that's really down to organizations, their policies, and how you want to work. But the key component here that differs significantly from the options that you have when using the ARM templates is everything needs to go through that workspace publish branch. It's when you hit that publish button within Azure Synapse that it generates the ARM templates and all of the components that you need to push it to a new environment in the background. And I'll show you what that looks like as well. So once that hits the workspace publish branch, our YAML pipeline gets triggered from that specific branch, and that triggers our continuous deployment pipeline, which will automatically deploy to our test environment. And then potentially we've got the option to add an approval gate, which will stop the deployment going to production until someone gives it the green light. And that deployment will be specific to that Git commit that updated the workspace publish branch. So if further changes have been made within dev, they don't affect it. Even if they're pushed up to the workspace publish branch, that becomes a whole new pipeline execution. So it's quite complicated. There's quite a few moving parts there. I cover a lot of this in more detail in some blog posts talking specifically about Data Factory, where most of the components are very similar to the way you would do it with Azure Synapse. The main difference being that extension and the method in which you're deploying things. Within Data Factory, you can do it all using the ARM templates because all of the components can be deployed that way. But within Synapse, as I said, things like notebooks and everything are not covered, and you need to use that specific Synapse deployment extension. So let's get into a demo and we can see what this looks like rather than talking about it. So starting off, I've created 3 environments within my Azure subscription. I've got a dev environment, I've got my UAT environment, and I've got my production environment. If you can't see them, they are all sitting in separate resource groups, and that's an important distinction as well. When you're deploying, if you use the workspace or the resource deployment method to deploy your resources using ARM templates, they all have to be in separate resource groups due to the permissions needed to set them up and deploy them, and you've got service account conflicts or the potential for service account conflicts. So they should all be in separate resource groups. Going to our development environment, what I'll do is I'll just jump in here, I'll make a change, I'll demonstrate how that might work. I'm going to do this on the main branch, which is a huge no-no, but for development purposes, rather than going through multiple branches and everything, it's a lot easier to demonstrate. So let's go into develop. I will open this notebook, and let's say I'll just make a change and I'll add a description in here. So I've added a short description, nothing significant. I'll commit the changes. That's committing them to the main branch, but nothing's triggered at this point. Nothing happens. I might have testing pipelines set up using a YAML pipeline file, but I don't have any of these set up here. Once that's completed, I can hit the publish button. And this just takes a minute or so to gather what's going to be published. It's ready to go. If I hit OK, it will publish that to my development environment. And while that's actually publishing, or once that's finished publishing, it will get ready and it'll generate the ARM templates in the background, and that's what will update the workspace publish branch. So while that's running away, I'll jump over to my Azure DevOps environment. And if you're not familiar with Azure DevOps, this is the pipeline section, which just outlines the pipelines that I've set up for each of those components. I'll come back to the Azure resources piece because I think it's still valid to talk about it and how you can set these up using YAML pipelines and the flexibility that you have. But looking specifically at the workspace resources, I've got one that's sitting ready to go from a previous iteration this morning. And we can already see that that one's kicked off. If I come back to Synapse, we can see generating templates has succeeded. So that's updated the workspace publish branch with these changes that I've made. So if I come back here, we can see this previous iteration deployed to my development environment, or my test environment, sorry, from development, and it's waiting to deploy to production. And the reason it's waiting is I've got an approval step in there that requires my review. So I can review that and I can let that proceed. You'll also notice as well, there's 2 errors in here saying no message found for this error. You can dig about in the actual execution steps for that pipeline, and for the extension, there is no errors in there. It just seems to be an erroneous message or an error that doesn't actually impact the deployment. So it's not something to worry about. So if I come back to the deployment that I have kicked off, so I'll go up here. I've actually got an approval gate on this as well. So if I hit review, I can actually approve this to go to my test environment. And just a little bit of info on Azure DevOps itself. You have the option to add all sorts of different types of gates in here. I'm using a specific type of job within YAML, which allows me to define environments that I'm deploying to. And within here, I can say someone can only deploy to this environment between specific hours. Or, for example, we can say this requires manual steps. So there's a gate put in here that stops the deployment. Someone can perform those manual steps and then it continues the deployment once you click OK. Or the approval gate that I demonstrated, which will email a manager or potentially a team lead to approve this before it can go out. So come back to the pipelines. This is now deploying to our testing environment. So checked out the workspace resources. It's going to deploy the Synapse workspace. Then a couple of things that we need to bear in mind is we have development resources in here. So if I close this, we go to manage, we go to our linked services. We've got a couple of resources in here for our workspace default SQL Server and our workspace default storage. I would highly recommend, if you're going to implement these deployment pipelines, is do not use them. If you want to use that resource that's there, the default workspace, is to recreate it as another linked service with a generic name. If you use that specific name and you've got pipelines connected to it, those pipelines are going to carry into your testing environment and they're going to be connected to the that dev named links service. And when they go into production, they're going to be connected to that dev named link service. So just to make things a lot easier and simpler is to use a more generic named link service, which allows you to not have to change that. We can change connection strings under the hood as we go through, and I'll show that in a second, but you don't need to change the names, and it means you don't have any dev named resources within your other environments. So coming back to the pipeline, I did say that that will carry them over into the UAT and the production environments, and that's where you want to remove them. If I come up to my actual YAML, and you may not be familiar with YAML, but this is a kind of in at the deep end approach. This is our YAML pipeline. It is all based in code. It's all kind of essentially handwritten, but there are components here that help you along. So as I mentioned, we've got this split into jobs and stages. So our stage for testing has got this single deployment job. Within that deployment job, I've got a Synapse workspace deployment, and I can actually hit the settings here and it brings up the UI on the right hand side. So it's not all manually typing things in. But one of the key things I'm providing is an override for the ARM parameters. So when you create specific link services within your Azure Synapse workspace, and the dev one, for example, when you push that to the workspace publish branch, if there's anything that requires secrets, if there's anything that's using encrypted passwords, for example, that will become a parameter for your ARM template, and you'll have to provide that. You can do so using what I've done here is using variables, or you can connect to a specific variable group within DevOps or a Key Vault instance so that they're entirely secure. But because we have to bring those over, we have to provide those connection string details and that information. I'm then doing a step to remove the SQL link services and also the ADLS link service, the ones that are named with dev, and I'm just using the AZ Synapse PowerShell command for that. And then I'll include all of these YAML pipeline files within my Git repo as well, if you want to have a look at them. The last step as well is something I got burned on recently, is to suspend the Synapse SQL pool. So although I don't actually have any dedicated pools that I'm using in this example or this demo, if you do have a dedicated pool, it will recreate it in each of the environments. And for that deployment to work between dev and test, for example, the dedicated pool has to be online within your dev environment, and then it will deploy it to test and it will make it online in test, and then it will deploy it to prod and it will make it online in prod. And what you have to do is a tidy up effort at the end is to turn it back off again within your dev environment, but then also you may want to turn it off again in your UAT or your test environment and also your production environment until it's needed. And that's something that I didn't have those steps in place, and I left them running over a couple of days and maxed out my my MSDN subscription. So it's definitely something to be aware of. So then we've got the production stage, and there's actually nothing in here that tells you that there is an approval gate, and that's one piece that is lacking within DevOps. The approval gate component is stored within the UI within DevOps. So we can see we've got the environment that we're using is prod. If I come over here and go to environments, click on production, I can see the full history. And if I press the three dots and go to approvals and checks, we can see that approval gate that I've added in there as well. So that's where it's stored, and that's the one component that you need to add manually when setting these initial pipelines up. Everything else is stored within that YAML file, and that's what will get picked up and used. Another piece as well is I'm using, if I go over to library, I'm using variable groups as well, so that for each of these deployment types, I can tell it that when I say workspace name, it's the UAT or the test workspace name. Or when I'm deploying the production piece, I actually mean the production workspace name. So that's all the components within DevOps. As I said, I won't go into this in too much detail. If you want to know more about DevOps, then we can have a chat in the chat afterwards, or if you check out my blog posts, some of the components within the Data Factory blog posts are very relevant to Synapse as well. So come back to that pipeline run, it is still running and deploying to Synapse. It's not the quickest process. You can see it's been running for 6 minutes and that will continue to run. So while that's still running in the background, I can show you the Azure resources component and how that differs. And also a little bit of a design choice that you can make when using YAML pipelines as well. So coming over to the Azure resources repository. So I've got the 2 repositories within Azure DevOps. I've got my Azure resources and my workspace resources. We've got the Synapse workspace JSON file, which is the ARM template for Synapse. And again, this one is already shared within my GitHub repo, so feel free to go in and have a look at it. I've added a few things to the default version of this, which allow you to provision a Spark pool, which I'll come on to. There's quite a few kind of key points to remember when using different resources. So that's a fairly standard ARM template, and it's all fed by parameters. So if I go up to my parameters file, I've got a different set of parameters for each environment that I'm deploying to. Looking at the UAT environment, I can go into my parameters and I can see I've got the location set, I've got the name of the Synapse pool that it's going to create. I've got the name of the storage account it's going to create. The file system is the first container that's going to be in it, so I'm just named it Synapse. We've got our SQL administrator login for our serverless. And if we come down, we've also got a few Boolean options here for whether you're using a new Spark pool. If it's already been created, is this the first time you're deploying this ARM template? So you need to set these to true for a storage account and your Spark pool. If not, if you're just iterating changes, then you can set these to false. One other thing as well is the Spark pool name. So I've got it set to Sparky for dev, and for our UAT and production, it's all set the same as well. If you have them set as a different name, you're going to have failures within your development, your deployment pipeline. It has to be the same name. It doesn't need to be the same specification between each of those. It just has to be the same name. And that applies to quite a few other scenarios. If you're using an integration runtime, and this is exactly the same with Azure Data Factory, if you're using a self-hosted integration runtime, it has to have the same name and the same type within each of your environments. So if it's in your first environment and it's connecting to one server that you have on premises, you can't create a linked version of that in your UAT and prod, because those would be different types to the development one, and you would create duplicates and you would have all sorts of problems. They all have to be the same name and the same type. To get around that, you can have 3 separate servers, one for each environment, if that's not possible, or you want to amalgamate them into just using one integration runtime. If it's a small use case, then you would need to provision a separate Synapse environment that only stores that integration runtime and then shares that out to the other environments. So that's something to bear in mind as well. So let's see if this is finished yet. And it's still running, 10 minutes, excellent. So I don't have a significant amount in there, but you can see it's still running for quite a while.
We have a question. Is it okay to ask a question, or do you want to carry on?
Yeah, jump in.
It's from Bob Duffy, so I blame him. One observation is we end up having a lot of work in the main branch that we can't publish feature branches to run non-single threaded pipelines without going through the main. Do you notice this? Anything? Maybe it's a Spark notebooks limitation.
Yeah, so if I understood that right, that's one of the problems that I see, where if you're using for the Azure resources, where it's deploying using ARM templates and you're actually deploying your physical resources, I say physical, virtual, you can have different branches triggered. So you can have YAML pipelines that when you deploy changes to those ARM templates to a dev branch, it only deploys to your development environment. And then if you want to push that up to a UAT branch, it then deploys to your UAT environment, and then have a separate prod branch for that. But the way Synapse works and Data Factory the same as well, is you've got that publish button is the gatekeeper. You have to hit that publish button to create the ARM templates. There's ways you can do it manually. There's a workaround for doing that within Azure Data Factory, which I don't believe applies to Synapse at the moment, but it is quite convoluted and kind of code heavy at the moment. That allows you to programmatically push the publish button. So you could have a development branch where you create all of the resources in there, and then you have that process kicked off that pushes the publish branch, so to speak. So yeah, you are locked into that kind of single threaded, everything has to go through main or whatever your collaboration branch is, that then takes it up to workspace publish. So it does become a bit of a bottleneck. Does that answer the question?
I'm sure it does.
Okay. So it's actually finished the deployment to Synapse, which is great, and it's now just going to go through the PowerShell scripts to remove the dev SQL link service and the dev ADLS link service. So if I jump over to my UAT environment and try and remember the changes that I made, I think it was the notebook, was it the taxi one? And let's see if I still have, I don't have it up there, but I think it was the description. Probably should have made a note of this before kicking off the pipeline. Let's see. Okay, so rather than spending 10 minutes trying to find this, it should have deployed to this environment with that description change. It may just need to be refreshed. But if I go into my link services, I can see these two dev or the dev link services are here. But if I refresh this, hopefully that's working in the background. It's completed everything and it's removed those dev link services. So it's completed that component. And now it's waiting for me to push that out to the production environment. If I go back, it's now got the option to the approval needed for pushing that to the production environment. I can approve that and just leave that to run, and that will push things out. So that's the kind of overall development pipeline when working with Azure Synapse. And a key component here is that your UAT environment or your test environment or anything outside of development is not connected to a Git repo. So we've just got that in Synapse Live mode, and you don't do development within those environments. For example, I had created a notebook in here, sorry, a SQL script. So a script created in UAT, oh no, because you shouldn't be doing that. Once that's in there, it's in the live version, it's not going to show up in any other environment. It's not going to carry forward into any other environment. So it becomes orphaned essentially. And that starts to add in risk around governance and management of each of the environments. So generally speaking, you would do your development in development or any of the environments that are connected to your Git repository, and then the code's pushed up through the environments from there. If you've not seen the Git integration piece, if you come to manage and then go to Git configuration, it's just here, and there's a fairly straightforward process to go through to set that up and connect it to GitHub and or the Azure DevOps Git repo as well. So let's see, have I covered everything? No, so there's an interesting thing to take a look at, and this took me down a bit of a rabbit hole. Is we've got our development environment and we've got these notebooks, and these notebooks are attached to our Spark pool, Sparky, which is great, that's fine, no problem. If I come into the UAT environment, I'll just give this a quick refresh. I'll look at the notebooks and click in. We can see these are also connected to Sparky, which is brilliant. And that's one of the benefits of using that same Spark pool name, is that it will pick that up based on its name. If you use a different name, or if you don't have a Spark pool, or if you use a different name, all of these are going to disconnect and they're not going to be able to connect. There is a parameterized file that you can add to your workspace publish branch, and it's deep within Microsoft's documentation. I've got a link in the references file, references README on my GitHub repo. But if you use that file, you can parameterize anything that's created within your environment in Dev. So we can parameterize what notebook, what Spark pool the notebooks are connected to. But that also adds in a lot more caveats that you have to have notebooks that have no spaces in them for the parameters to work properly. That's the first issue. And the second issue is that's done on a notebook by notebook basis, which is fine if you have 2 or 3 for a demo, but as soon as you start to get multiple notebooks, you're adding a parameter to your YAML file for every single one. So if you do have a differently named Spark pool, the only way around it is to do some sort of find and replace in the process. And just now, that's not really possible when using your pipelines. There's not really an easy way to go into those workspace publish branches to do it. You would probably have to write a custom PowerShell code, PowerShell script that does it as part of this pipeline. So where we would potentially go through each of the deployment components, you would have to have a task in there that looks at those files that have been brought out of your Git repo, does a find and replace, and then continues on with the deployment. So that's a little bit tedious, to say the least. So if I come back to the slides, I've got a really good one for in-person conferences where this is the one you want to take a photo of. This is the one you want to note down. It's text heavy, but these are very important components that you need to remember when setting up the continuous deployment pipelines. So if you're watching this back on the video as well, you probably want to pause at this point. Integration runtimes need to be the same type in all the environments for them to deploy properly. Your artifacts will deploy as ARM templates, but as soon as you start adding in things like notebooks, your Spark pool components, that's going to fail. It's going to stop working. So right from the start, remember to use the Azure DevOps Synapse deployment extension. All the resources that you need have to be in all of the environments that you're deploying to. If you've got a Spark pool set up in your development environment and you don't have it in UAT, you're going to get failures. It can't create that on the fly. It can't deploy notebooks pointing to a Spark pool if there's nothing there. As I mentioned, try to avoid using the built-in link services because it's just going to pollute all of your other environments with these locked-in dev link services. Dedicated pools also need to be online in the target environments and also the source for pulling that out. Your notebook pool connections, as I just mentioned, need to be updated either manually or using a find and replace if you don't use the same name. And also your template updates have to go through that workspace publish branch. The AZ Synapse module is great. I've only used it for a few components to delete the link services and stop my dedicated pool, but there's a lot more functionality in there and it's definitely worth checking out. The documentation is actually really good as well, so it's definitely worth having a look. And then finally, your dedicated pool objects won't be handled by either of these processes or the deployment pipelines. You need to add in that component that I mentioned that's in Kevin Chant's blog post. He mentioned it on Twitter yesterday if you want to grab it before I get that added to my GitHub repo. So finally, you're probably thinking there's a lot of steps in there. There's a lot of manual pieces. There's a lot of pitfalls as well. So is this DevOps and Synapse? Is this where we are? A few things I'd say about that is this is the movement of code between environments as it is just now. You're probably already aware of how quickly Synapse is developing, how quickly updates are coming out and changes and things are improving. So it is constantly evolving. So there may be significant improvements on the horizon. There may be things that take this small technical component and flesh it out to be more more encompassing. It's something that we'll just need to wait and see. The actual process, the deployment process, is still in its infancy. We can see developments in Data Factory that are trying to tackle the same thing, that same bottleneck with the publish branch. So hopefully that those components and those enhancements will come across to Synapse and maybe even get better because Synapse has got a lot more components and pieces to it. And also the DevOps extension, although it has got a lot of bad reviews attached to it in the Visual Studio Marketplace, it is getting better. And once, if you use the pipelines that I've set up and the kind of processes, it seems to work and it seems to be stable. I'm not coming across a lot of the issues that people are reporting within those comments as well. So there is light at the end of the tunnel with that. And that's everything I have. So thank you very much for listening. And if you want to get in touch, all my details are there. As I said, I'm happy to chat about any of the components in more depth within the comments. And that's everything. Thanks.